Because you know I'm all about that bass in math class. I'm all about that bass, logarithms. I'm all about that bass, I love functions. I'm all about that bass, bass. Yeah,
all right, here's 7.2 Intro to Logarithms. This video shouldn't be that long, so hopefully it'll be a good one, very quick, ready to go. So logarithms basically are another way to use exponents, and in real life applications there's two specific examples that we can use. One is, again, for earthquakes. We say it right here for earthquakes, and hopefully if you've taken science or whatever, you know that earthquakes are usually measured in the Richter scale. Some dude named Richter, I'm guessing, and I'll show you some videos of some earthquakes that occur as well. And then the other one for sound is what we call the decibel level. Basically, it measures how not necessarily how loud something is, but kind of in that same general realm. Like if I'm whispering right now, then my decibel level's really low. But if I'm yelling right now, then my decibel level's even higher. Okay, basically it's just so that your ears and stuff don't, your eardrums and stuff don't burst. And I'll show you some things about that too. All right, here's video of the earthquake in Japan in 2011. This is from high rises. You can tell that those buildings are shaking. They're literally moving left and right, and they're swaying feet upon feet, not just inches. So just think about what an earthquake actually does. It's shaking a building that big. So definition of a logarithm. This is going to be very important here. So this is y equals log base b of x if and only if b to the y equals x. Okay, so basically what happens is this is in logarithmic form. This is what we call log form or logarithmic form. Okay, and this right here is what we call exponential form. Remember last section we talked about graphing exponential functions? This is kind of what we're doing here. And remember the variables in the exponent, or yeah, the variables in the exponent here. So in this case, the log base b of x, well, this is base b, and then I'm raising it to the number on the right, on the left-hand side, this y value, and it equals the x value over here. That's what it basically says. We'll get to some examples. It'll make more sense down the road, but because this is the first time we're dealing with logs, we're going to not really understand what it is. So we'll get some examples. Don't worry about it. Really not that bad. Okay, don't be frustrated yet. So here are some different things that has to occur. B has to be greater than 0. This cannot be a negative number ever, ever, ever. B cannot equal 1. Okay, B cannot equal 1. Right? It just says it right there. And x cannot be 0. Okay, this number cannot be 0. The y value can be 0. That's okay. But the x value can't be 0, b can't be 0, and b cannot equal 1. So let's go on down a little bit. It says, how do you say this right here? Well, this is how you say it. This is called log base b of x. Log base b of x. If you say it any other way, you will be wrong. Please make sure you understand that. I will be asking you when you turn this packet in and get your power assignment what this is and how to say it. Okay, and if you say it wrong, then we're going to have a deep discussion. Okay, log base b of x. We'll talk about what the bases are and stuff like that when we get into some practice problems in the next couple examples here. Okay, the first one, I want to write this first one here in exponential form. We can already see that it's in log form because this has a log in it. If it has a log, it's in logarithmic form. And I want to write it this way, where b to the y equals x. Well, what value is our b, our base? Well, our base is 3, so 3. And then our y over here is that 5, so it's 3 to the 5th power equals 243. What this means is this base, 3, this is still our base here, right? Remember, if I have an exponent that's some number, say 2 to the 2 power, this is our base, and this is our exponent. So it's the same way back in 7th grade when you started talking about exponents, 6th grade, whatever it was. Big number here, b, big number base, right? Stands for base. Same thing here. So 3 to the 5th power is, if you were to plug this in your calculator, you actually do get 243. That's the point of logarithmic form. Just another way to write it so we can do like harder problems, okay? Number 2 here, again, I want to write it differently. So take the base. Base is 5. What is the y value? Well, that's 3. So 5 to the third equals 125. That's pretty self-explanatory right there. I want you guys to pause the video and try the next 2 problems. And you wonder why you have to wear earplugs. So number 3 here, this is 9 to the 0 power equals 1. Now, this is kind of another trick or a different kind of strategy, but if I take log base b, meaning if it could be anything, it could be 50, it could be 100, it can be 1,012, it doesn't matter. And if I take that log base b of 1 to the 0 power, it's always going to look like this. Okay, I'm always, any number, right, b to the 0 is always equal to 1. We should have known that from exponent form back in 6.4. Any number to the 0 equals 1. So that's kind of a neat little trick there. It's really not a trick. I guess it's like an equation that you can use, or some sort of important concept. But number 4 here. So I can take the 1/2, that is my base, so it's really 0.5, raise it to the -4 power, and that equals 16. And if I think about it, let's do the fraction here. So it's 1/2 to the -4. Well, what happens to a negative? This flips, so it's really 2 to the 4th equals 16. So it does equal true. All right, so 1/2 to the -4 equals 16, and that's our answer there. You can even use 0.5, that's okay too. All right, so that's how you rewrite it into exponential form. Now I want to go backwards. So I want to write it from exponential into logarithmic form. Again, my 3 is my base. So now this is log base 3. This 3 is like a subscript. Please make sure you do not write log 3. Please don't ever do that. Ever, 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 ever. Make it like a little subscript, okay? Now, equals what and all this stuff? Well, this number here technically is my x, right? So that's 9. So log base 3 of 9 is equal to 2. Basically what happens is this number switches and this number switches, if you think about it. Okay, so the same thing here. Log base 2, this number switches, 32, equals this number switches, 5. It's another way to write it. All right, I want you guys to do 7 and 8. Try them, hit pause, and hit play. Number 7, okay, number 7. So again, a log base 5. This number switches, and this number switches. So there we go there. Number 8 looks a little different. And the reason why it looks a little different, because it's really 64 to the 1/3. Remember from 6.1, 6.2 in that area, this can be written as a fractional exponent 1/3. So now what happens? Well, it's log base 64 of 4 equals 1/3. So that is how that is written. Some of you probably didn't do this because you didn't remember how to do it. Okay, so now you know. Remember, we talked about logarithms are basically square roots, cube roots, all that stuff. Exponents are all in disguise. They're in disguise. We're talking about like shady answers. Well, they're kind of shady again. Man, this is great. Math rocks. All right, let's get into the next section here. For number 9, 10, 11, and 12, you are not going to be given a calculator. You're not going to be allowed to use one. So even on the PA, you cannot use a calculator at all until you get to a specific section. I don't even know if I'm going to have some of these on there, but you cannot get to, you cannot use one at all. Cannot use at all. Okay, so why is that? Well, mainly because these are going to work out really nice, and we have to understand what logs are without using a calculator. And the calculator won't really do this for us without going to the next section, so we can't do this yet anyway. If I look at log base 2 of 8, I want to find out what this equals. So I'm going to find out, I'm going to make it an x. So log base 2 of 8 equals x. I want to find this x value. Well, how do I do this? Well, from the other part, I'm going to write this in exponential form. This is really 2 to the power of x equals 8. Well, 2 to what power equals 8? 2 to the first power? And that's not 8, that's only 2. 2 to the 2? That's only 4. 2 to the 3 is 8. So x equals 3. That's our answer for this problem, 3. That's it. That's all we're doing. Not that bad. The second one here, log base 7 of 1/7. So what happens? It's what? 7 to the x equals 1/7. Now, if you recall, the only way I can get fractions from whole numbers or vice versa, right? Fractions to whole numbers or whole numbers to fractions is by having negative exponents in my numerator. Well, 7 to the first power is just 7. 7 to the 0 power is 1. 7 to the negative 1 power is going to be 1 over 7. Remember, a negative 1 flips it, and that's how I get 1 over 7. Okay, I want you to do 11 and 12, hit pause, and then hit play. Number 11, I want to, again, find out what the x is there. So it's 1/3 to the x power equals 81. Well, now I have a fraction, and I need to get to a whole number. So this x we know has to be negative. I don't know what the number is yet, but I'll figure it out here. Now, 3 to what power? So once I turn this negative, it flips. So now it's really 3 to something. 3 to what power is 81? Well, what's 3 to the first? That's not 81. 3 to the 2? Nope. 3 to the 3? Heck no. 3 to the 4? Yuppers. So this is to the fourth power, but it's a negative 4 because I needed to flip the fraction. So this one here is a negative 4. Number 12, I have 25 to the x equals 5. Well, that's weird. They're both whole numbers, but how do I go from a bigger whole number to a smaller whole number? Well, interesting. Well, that's where square roots come in. If I take the square root of 25, I get 5. But remember from back in Unit 6, where a square root is technically the 1/2 power. And a cubed root is the 1/3 power, and so on. So technically, my answer here is 1/2. We have to remember stuff from previous lessons, especially Unit 6, because Unit 6 and Unit 7 go hand in hand. They're like walking on the beach, holding hands, and then all of a sudden you have like 4 footsteps that turn into like 2 footsteps because one's carrying the other away off into the sunset. Okay, well, that was a fun off-topic kind of thing. Let's go into the common logarithm and natural logarithm. Well, this here is log base 10 of x. Well, our decimal system is 10 if we think about our number system, counting system, right? It's all base 10. So we can actually rewrite this as log of x. We don't even have to say base 10 because it's understood that if I don't say the base, then it's just going to be base 10. And that's the way your calculator technically will look at it as well. And I'll pull that up and I'll show you how to use it, because we're going to need to use it on these problems down here. So the natural log. Well, a natural log, we're still using logs, but now we're going to use this letter E. So that E stands for something, and we're not going to get into actually what that is, but it's not a big deal. So natural log, we have this other thing. It's called ln of x. ln stands for natural log. Don't ask why they didn't put NL. Don't know, but they put ln and then of x. Because our base is E. Our base in a natural log is E. Our base in a regular log is 10. Okay, we need to understand that. This is base 10, and this is base E. We need to understand. Hugely important. Hugely important right there. Okay, you need to understand that. All right, let's get into 13 and 14, and we'll do some calculator stuff. You will be able to use a calculator on this if we have this on the power assignment. Okay, log of 13. Okay, basically it's base 10, right? And your calculator will do it for you. If you look next to the 7 button, it says LOG for log. You're going to hit that, and then hit 13, and then enter, or then close parentheses and then enter. And what does this approximate at? Well, it approximates at 1.113. 1.113, and it'll tell you if you want to round to the nearest hundredth or tenth or whatever. That's not a big deal. But what I want you guys to do is do number 14. It's a natural log, and I want you to find that one. The natural log button is right underneath the log button. ln right there. Okay, so ln of 6. What do I get? ln of 6. What do I get? What do I get? What do I get? Oh my gosh, I get 1.791 or 1.792, I guess. 1.792. That would be okay. That's not a big deal. All right, here we go. So things that simplify. This is the last section before your practice. This is pretty simple. It's a pretty fast video, I think, too. So things that simplify. So what happens is if I have a log base b of the letter b to a power, because they're the same bases, what happens to these? Well, these just cancel. And what am I left with? I'm just left with that number x. So if I have log base b of b to the x, the b's cancel, the logs cancel, and what drops? This x just drops it like it's hot down is my answer. Well, the same thing here on number 2. If I have a base b raised to a log with the same base, So b raised to a log base b of the x, that just cancels as well, goes away, and then that x just drops down. And that'll help us in the next section as well. I don't know if this will be on the power assignment, but it will kind of help us in 7.3. So simplify. Well, what happens? Remember we said if I don't have a number there, it's always base 10. So the bases are the same, so that 10 and that log just cancel, and what drops? That 6 just drops it like it's hot. Number 16. Well, this log base 3 of 9x, well, this isn't a 3, but can I make this a 3? Well, yeah, I can. It's really 3 squared, right? And then all of that to the x power. So let me rewrite this. It's log base 3 of 3 squared raised to the x. Well, what happens? These two gets multiplied together, so it's really log base 3 of 3 to the 2x. But now it's log base 3 of 3, so those cancel, and then the 2x drops down as your answer. All right, I want you to try 17 and 18. In 17, what is our base on the ln function? Well, the base is e, right? So it's e to the ln of e. So what happens? Those just cancel, and then the 3x just drops down. It's just 3x. This one here, ln base e of e to the x to the half, right? Or x over 2. So the ln of e, base e, and all that stuff cancel, and then the x over 2 just drops down, and that is your answer. Okay? That's it. That's the section. Not a bad section. It's not really hard. Remember, on the power assignment, you are not going to use a calculator. Here's a little calculator right here. Here's your little screen right there, and you got your buttons and stuff. No, you cannot use it. Okay, that kind of looks like a little floppy disk that is like on your computers for like the save button. Okay, sorry, my calculator icon's not very good. But seriously, you're not going to be able to use it. Please make sure you understand how to do it without a calculator. It's not difficult. Again, you can use calculators on these ones here, but I don't know how many of those I'll put on there. So not a big deal. Wharton, signing out. Take notes, do work, and you'll find success.